Saxon Algebra 2, Lesson 107. I hope wherever you are, whenever you're watching this, you are having as glorious a day as we are having. It's April, spring has sprung, the flowers are blooming, the grass is green. It is a glorious day to do some math. So let's talk about number word problems. These are a little different than anything, excuse me, we've ever done before. They're a tiny bit mind-bendy, but once I explain, I think you'll understand. And we're not really going to build on this, but they do show up quite often in standardized tests. So they're worth a little bit of effort. There are two words that we use in math, and let me tell you what they are. Numeral and number. Now, way back when you were a little kid, somebody probably explained those words to you, and you probably don't remember, so I'm going to assume you don't remember. When we talk about the word numeral, what we're describing is the symbols that we use for math. When we want to talk about one of an item, we use this. It's a stick, right? When we want to talk about that many of an item, we make this shape. The next number in the sequence looks like that, right? There's symbols that we have learned have a certain amount of meaning, right? Numbers are when we use the symbols with an understood value. A number is more complex. We take the basic symbol and then we give it additional meaning. Let me show you what I'm talking about. When we write that, we are using two of the symbols, right? A 2 and then a 0 and a 0. Those are the symbols. But this has a very different understood value than that number, which uses the very same symbols, but this has a different understood value than this. These are the same numerals, but these are different numbers, right? So we can say here, same numerals, different numbers. This is not just a theoretical distinction I'm making. In our problems today, we're going to take advantage of this distinction. Let me show you another thing that you probably did when you were a little kid. You probably learned to write this number by saying this represents 2 times 10, right? Because the 2 is in the tens place, plus 3 times 1, because the 3 is in the ones place. We did a lot of this kind of work when my kids were in like elementary school, learning to understand the place value of numbers. What we're going to do is we're going to take this same relationship. Let me do one thing though. I want to write this. If we switched around the numbers, we can take the very same numerals and create a different number by changing their place, right? And we know that this equals now 3 times 10, right? Here the 3 was in the ones place, so we multiply it by 1. Here the 3 is in the tens place, so we multiply it by 10. And the 2 is doing the exact opposite, right? Here it was in the tens place, now it's in the ones place, all right? So this, I don't think, is hard for you to understand. What we're gonna do is we're gonna take this pattern and we're going to come up with a way to write it as a formula, because that's what we're going to need for our problem. So what we can say is that T equals the numeral in the tens place, and U equals the numeral in the ones place, okay? John calls it the units place. so that we're not using an O for 1, which would be confused with a 0. So he's just going to call it the units place. That makes me feel a little bit backwards. But if we have a number with a number in the tens place and the number in the ones place, we know that we can write it as t times 10 plus the number in the units place times 1. Make sense? Then what we can do, just like we did here, we can flip it. And the number that was in the units place is now in the tens place. And the number that was in the tens place is now in the units place. So if we flip them, then we take this number and multiply it by 10. Okay? So the number that was in the tens place becomes the number in the ones place, and we change the way we're multiplying it accordingly. The number in the ones place becomes the number in the tens place, and we change the way we're multiplying that. Here's the very same thing being done with letters instead of numbers. Here, this is the t is like the 2. Here it's multiplied by 10. Then we move it to this other place and we multiply it by 1. And then the same thing, the u is like the 3, right? It starts out in the ones place and then we bump it up to the tens place. This is, let me just write this. We're switching the order of the digits, and we're doing the same switch here. And what we're doing is we're saying we're using the same numerals, but we're creating different numbers with them because the understood value is changing as we flip the order that we write them. This is what we're going to need for our problem. All right, so let me just go to the next page and we'll write one more thing. We're going to call t is the numeral in the tens place, and u is the numeral in the unit or ones place. So TU is what we call our original number. Okay, then when we flip the numerals, or as John often calls it, we reverse the digits, this is the number with the reversed digits. Okay, the value of the original number, which we just did on the other page, is, and we can write it a little bit simpler, right? 10t plus u. That's the same as what I did here, right? 10t plus u times 1 is just u. So I just cleaned this up a little bit. 10t plus u is the value of the original number, and then the value of the reversed number, if you will. Okay, that's like this, right? The u is multiplied by 10, and the t is times 1, so we can write it as 10u plus t. Once we get this laid out, the problem becomes very straightforward, the problems, all right? So this is what you need to wrap your head around, okay? This is the first, these aren't being multiplied, these are just like being listed as they would show up in a number, right? Like 23 and 32. So don't assume multiplication there. All right, we're gonna need to use these phrases in our problems. So let's do that. I am going to pull this page out of my notebook so that I can show it to you again as we work the problems. All right, example 107.1. Let's see how many examples there are in this lesson. Just 2. Okay. Take that out. 107.1. Hang on, I don't have my book open to the right page. It's like, why am I so confused in trying to read you this problem? Oh, the book's not open to the right page. That's the problem. Okay, ready? The sum of the digits in a 2-digit counting number is 11. The sum of the digits, okay, so that means that if we take the number in the tens place plus the number in the ones place and we add them, because it said sum, so that means adding, the sum is 11. We just wrote an equation describing this. It's a system of equations problems. I should have said that. If the digits are reversed, the new number is greater than the old number. Okay, if the digits are reversed, that means this. So 10u plus t, if the digits are reversed, the number is greater than, and I'm not going to tell you by how much, the original number. We write the value of the original number like this. If the digits are reversed, the new number is greater than the original number, okay? And again, this that I put in our notes, this is exactly what we need here. The value of the reverse digits is greater than the value of the original digits by 27. So this is the bigger side, right? This is what this is telling me. This is greater, this is lesser. So I'm gonna add my balancing number right there. And now I've got an equation, system of equations we solve. All right? Setting that up is tricky, but if you have this information in front of you, it's gonna get a whole lot easier. Now, these problems are always a little bit unusual in that before we actually decide, do we want to substitute or eliminate or whatever, we have to clean up the bottom equation, okay? And we can see that we're going to be in good shape to substitute here. Let's just clean this up first, and then we'll decide how we want to rearrange this to plug it in. So what I see is that I have t's and u's on both sides. So I'm going to subtract this t and bring it over here. And I'm going to subtract this u and bring it over here. Now let's see what we have. This cancels, and I get 9u equals 9t plus 27. All right. Let's solve this for, I don't know which one. Let's solve it for t. So we're going to take this and we're going to say t equals 11 minus u. All right, and so I'm going to put this in right here. That's the expression. So it will become 9u equals 9, 11 minus u, plus 27. All right, I'm gonna have to distribute here, so let's do that next. 99 minus 9u plus 27. Okay, I'm gonna add 9u to both sides, and then I'm gonna put those two guys together. Add 99 and 27, they are like terms. So I'm doing two things in one step. This cancels, this becomes 18u equals, let's see, if we take 1 from the 27 and give it to the 99, that will make 100. So then this will be 126, right? Divide both sides by 18. Okay, and what my brain tells me to do is I want to multiply some number times 18 and I want to get 126. So I think to myself, what other factor multiplied by 8 would end up with a 6? 8 times 2 is 16, but I know it's not 2 because that's not, this will, 2 times 18 would only be 36. And this is a whole lot bigger than 36. So what else times 8 equals 6? I think of 56. 8 times 7 equals 56. So let's try multiplying 18 times 7 and see if we get 126. That's 56. 7 times 1 is 7 plus 5 is 12. There it is. So I know that this reduces to 7. And those go away. So I get that the number in the units place in the original number is 7. And I know that the number in the tens place is going to be 11 minus 7. So the number in the tens place must be 4. And that means that the original number equals 47. And that's the right answer. It's kind of fun, right? This whole tens and use things is weird when you start using it. But again, if you can understand what I'm doing here, you've got everything you need to start working these problems. It'll make more sense as you go. Isn't that the story? Well, I was going to say, isn't that the story of math, that things just make more sense as you go? That is the story of life too, right? I don't want to say fake it till you make it, but kind of, yeah. You just have to do things, and then after a while they'll feel normal and natural. Okay, let's do the second one and then we'll be done. See, you get math concepts and life lessons. Isn't it amazing? 107.2. We're going to use those same equations. I've got them handy. The sum of the digits in a 2-digit counting number was 9. Okay, so the number in the tens place plus the number in the units place add up to 9. When the digits were reversed, the new number, that's this one, 10u plus t. The new number, let me go back to reading it, was less than, I'm not going to tell you how many less than, the original number. And the original number is 10t plus u. Right, 10t plus u. All right, now we need to balance it. The new number was less than the original number, yes. The new number was 45 less. Okay, so what do? This one's smaller, this one's larger. That's what this tells us. This one's larger. I always like to adjust over here. You know me, I have room for it. So I'm going to subtract 45 in this one to make it balance. Okay, now it's an equation. There we go. Just like before, we can clean up this side and then we'll rearrange this and substitute it in, right? So we're substituting. Okay, what some people like to do, last time I moved like the single pieces. Some people like to bring both the t and the u over to this side. So let's try that this time. Minus 10t minus 10t minus u minus u. These cancel, and now we get 9u minus 9t equals minus 45. Some people like this presentation because this is the way we often arrange equations when we're doing system of equation problems, right? We put the 2 letters over here and the plain number over here. It's fine. It's perfectly fine to do it this way. It's also perfectly fine to do it the other way and just leave the u's, scatter the numbers. You can do it either way. There's no right or wrong. I've showed you 2 different ways. It's fine. Last time we solved for t. This time let's solve for u, just to mix it up. So u equals 9 minus t, and that's going to go right there. Right? There's the u, and there's the u. So that's what we'll plug in. So it becomes 9 times the quantity, 9 minus t, minus 9t. Oh my gosh, lots of 9's and t's, right? And this equals minus 45. That always makes me a little nervous when we have a minus sign just hanging out like that, because shoot, it's easy to forget. Okay, ready? 81 minus 9t minus 9t equals minus 45. All right. And I'm going to combine like terms here. Let's swim this 81 across. That makes me a little nervous because I see I'm making a really big negative number. But I also see, oh, this is going to be a negative number, so we'll be dividing and it'll all work out fine. I'll show you what I mean. This cancels. This comes to minus 18t. And this comes, let's see, these are both negative, so it's going to be 120. Is that right? Is negative 126. We divide both sides by negative 18. We see the minuses are going to work out. We just did this. We know that it's 18 times 7. Or yeah, 126 equals 18 times 7. So this cancels and we get a positive 7. This cancels. So this time we get t equals 7. We got a 7 in our last problem, but it was in the ones place. So it's a different problem, but it's funny how the numbers just worked out. Now we need to find our units place number. The units place number is equal to 9 minus t. T is 7, so the units place number is 2. Right? They add up to 9, which is just what we said. So that makes me feel good. And so I'm going to write original number is 72, right? We set our T's and U's up so that they're right for the final number. And that's the right answer. Yay! Number word problems. Again, if you can keep this straight in your head, that takes the trippiness out of them. And once you do a few, you'll be able to see the logic of it. And hopefully when they pop up on some standardized test someday, you'll be like, oh yeah, I know how to do this. Look, we're almost done with the third week. Very exciting. Okay, thank you. Goodbye.